Welcome to the APL Show. I'm Adam Botsevsky, and with me I have
Rich Park.
And we are going to continue from the last episode where we were reacting to this video. Change the way you write, change the way you think. But before we continue with that, Richard has an announcement.
Last week we hosted the APL Seeds 23 online user meeting. That was a great time. Had lots of fun talking with new and experienced APLers all together. Recordings from that day should be published by the time that this recording comes out, or at least very close together. So you can go to dialogue.tv to check those out, or maybe we'll link to a blog post or something that is a central link where you can find out information, a little bit of text about each presentation, and then links to all the videos. Yeah, that's it.
So I guess we continue.
I think so. This I'll try a little bit to remember the context, because at the beginning he's talking about notations and stuff, and then I guess the end of where we got up to was he does mention some APL examples and talks about inner product and stuff. But I think from here on out, if I remember, it's other notations. It's talking about all kinds of different tools, software tools for doing different things. So I think that's what we're going to see.
Well, we will see.
So therein lies the first tension of this talk, what we call programming in the large versus programming in the small. This concept was created in 1975, and in 2022, we're still not very good at solving it. So I want you to consider a program that is written in Spark, right? By and large, we can consider this a program in the large because it's going to run on many machines, a cluster of machines, and it's the kind of program that many people will touch, right? So the real result is that we have individual programmers who have to follow a rigid set of rules and run the clusters when they want to do and try something, right? It's quite hard to use when you compare it with immediately coding up a solution on your computer. The Spark ecosystem leaves very little room for personal sparks of creativity, which will often solve a problem in a much far superior way. So, question is this: what do we prefer? Do we prefer to work within a rigid rule set that offers no creativity, or do we want to work?
Quick, before he answers, what do you prefer? Well,
obviously,
what's he describing? Large systems with rigid rules where you have to abide by those rules, and I guess you have less flexibility.
Yeah, obviously, I prefer the small thing where I'm free to express myself. I mean, what can I say?
The implication is that the advantage of the large system is the scaling, the maintenance.
There must be some kind of tipping point. If you end up, as you're speaking about these sparks of creativity, you might be able to come up with a better algorithm, a more efficient algorithm. So where's the tipping point where you throw more brute power at the problem and it runs faster because it's on a supercomputing cluster than doing it on a small computer with a better algorithm, because you're able to experiment and express yourself better. Obviously, nobody can answer that.
Yes,
but
it depends.
Yeah, but it's interesting, and
with personal flair.
Sorry.
No, I'm saying it's just an interesting consideration. You might be able to run things faster because you have a better algorithm, even on a small computer compared to a supercomputer. Certainly for some problems.
Yeah, and if your algorithm's sufficiently bad,
then you'll never finish even with a supercomputer.
Yeah. Anything else? I guess that's the typical APL story is leaning towards, even though we know and we're aware of large systems that exist written in APL, the typical user story is that it leans towards the small and the direct contribution of like people solving the problems, in contrast to the types of IT experts who are required in order to set up these large systems. And that's a slightly ongoing conflict, I'd say.
Yeah, but I think there can be a huge difference even from a small change. Let's say you got unacceptable performance. You can't push more performance out with your current algorithm out of a single computer. Going from running a system on a single computer to running it on a cluster on some large interconnected cloud thingy or whatever it might be, is a huge step. And there's enormous overhead that you're adding. If you're able to just make it a little bit more efficient locally and then be able to make it a little bit more efficient and then you can run it locally instead on a single computer, that can be enormous cost saving, energy saving.
Yeah.
So there could be, it could be beneficial to at least do prototyping in the small to come up with better algorithms. You might need to eventually port to something large, but you'll be able to develop small, at least programming in the small.
Right? There is this notion of that Gerd Hofstadter came up with, individualistic cultures and collectivist cultures. And in the context of software development, in the context of data science and data engineering, we often have to choose a side. So what ends up happening is the data scientists will all code, with personal flair on their Jupyter notebooks, and the data engineers will come in and wrap the processors around that. That's a bit complicated, basically. The question is this: is there a way to eat your cake and have it too? And I think the answer is yes, through the use of multiple notations, which I'll discuss in a bit. But first, I want to continue on this digression on programming in the large. Russ Cox, the co-creator of the Go programming language, has been known to say that software engineering is what happens to code when you add time and other developers, other programmers. It's a riff on this quote by Titus Winters, of course. Now let me turn this question around and focus it on data engineering. What happens to your data engineering stuff when you add other programmers and time and other data scientists? So today we see many products to the tune of, oh, it's simple. We will take your Jupyter notebook, we'll wrap it up in a REST or a gRPC service, just chuck a load balancer in front of it and you're golden. That's not a problem, okay? I want to make it clear, it's not a problem, because we do live in a society that rewards fast turnaround, right? The faster you can package up Stable Diffusion into a product, the faster the VCs are going to come knocking on your door to give you money. But what happens when you add time and other programmers? Well, you'll end up with an ecosystem of overly complicated processes. Now everyone has to specialize a bit, and that sucks because I'm a human being, and specialization is for insects. Now,
specialization is for insects. Yeah, also, I just wanted to take a little glance over all this.
That's a lot of stuff.
And they're reminiscent of the XKCD about standards, I guess.
Yeah. You gotta wrap this in some other thing to make it easier. Now you've got one more thing that you need to be able to use. I find this with libraries in general. Adding a library has a huge cost. It has to be really worth it for it to be worth it. Because if it doesn't really add a lot of ease to what I do, there's so much more that needs to be learned and taken care of and updated and dependencies and whatever not. But what he's saying actually reminds me of something my father said. See if I can find it. Let's see.
Yeah, some of these things are they're just words to me.
Sure. Here we go. So, my father registered a like a patent trademark something with this logo.
Oh yeah.
And he used this as promotion for his APL consulting business. This is way long time ago, so you couldn't easily typeset this. That's why it's all handwritten. Yeah, it keeps going around and around. Yeah, it's circular, right?
Communication means faster. Coding means fewer coders, means easier communication, means faster coding, means fewer coders, means easier communication.
And it keeps going like that, right?
Yeah.
And he's using that as a symbol of the APL
Yes.
programming, right? And in the video we're watching here, you notice this also, that you have these groups of people. There are the domain experts, right? And then there are the programmers.
Yes.
Having that split has an enormous cost again.
Mm.
As long as your domain expert is able to write his code by himself, all the misunderstandings and specification documents and reviews and cycles in the development, they just don't exist. Right? The domain expert, he knows what it is he wants. He knows what the algorithm is. He's an expert on this field. He just needs to express it in such a way that the computer will do the work for him.
Yes.
But when you throw in programmers that do not know this field, right, then he needs to explain to them, oh, but this is how it works. And maybe he can't express it in a human language that's easy to understand. But if he has a specification language that's also executable, that is easy enough for him to use, then he can express it with that. And there's also a way that my father taught me to program APL in a top-down manner. He would write like a sentence saying, stating what it is I'm after in APL. For example, the primes until 100.
Yeah.
And then he would execute that in APL, and APL would respond value error until. It doesn't know what that word means. And then he'd say, well, until that means the numbers from 1 onto that number, which is just iota. So we define until as being just a cover for iota. Okay, so we run it again, primes until, and now it gives a value error on primes. It doesn't know what that is. So I say, well, primes are numbers that have exactly 2 divisors. And then you try again, and now it steps into primes, and it gives a value error on the divisors, and so on. And you define each of these until you can define them in terms of primitives, and then the program runs, and you're done. You go home.
Yes.
Right? There was never any spec. There was never any discussion with anybody. You just explain what it is, and he said this is how he would work as a consultant for companies at the time when factories and so on were computerizing. He would go in and ask people, what are you doing? And he would write that down. They say, what does that mean? What does that mean? What does that mean? Does that mean? Until they have completely specified it in terms of APL primitives, what it is to do, and then you run the code, and then they would ask him. After he's asked all these questions, he said, okay, there's no more questions. Then they ask him how long time does he estimate that it will take for him to code this up? And he said, oh no, it's done. Here you go. Now it runs.
Well, that's feels slightly idealized in this day and age.
Yeah, there's a
with
lot.
other
The world is
requirements.
a lot more complex, and that's true. But the idea here is the more you can cut
Yeah.
out of these layers, the better results you'll have.
Yes.
Are you
And
done
more
looking at the
directly
list here?
Yeah, I'm done looking at the list. Go on.
What I'm trying to say is this is not a knock on these products. I use many of these tools myself, but it's often I sit down and think, why do we really need this? Right? Sure, some of these are what Fred Brooks would call essential complexity, but I would say that majority of these things are accidental complexity that comes out from not sitting down and thinking our problems through. And as data, how do we think about problems, right? As mentioned earlier, when we solve problems, we're actually establishing the rules of how the elements of the problems can interact with one another.
By the way, for the listeners, he's now showing the words on good notation or on good notations.
And when there are rules and elements, we call it a language. And when that language is written down, we call that a notation. As data engineers, the elements are things like the database, the machine learning algorithm, the Jupyter notebook. Right? The rules are not whether we can add a string to an integer, but rather how we can keep our data in the correct shape and form across time and space and people. Who here hasn't dealt with, multiple sources of truth for one thing, right? People who apply data mesh without actually applying data mesh, that is. So
You're probably going to say what this is.
Iverson bloke. Ken Iverson won the Turing Award in 1979, and in his Turing Award speech is actually called Notation as a Tool of Thought. Good notation often leads to new discoveries. For example, by by simply inventing a new notation, John Conway from the aforementioned Conway's Game of Life, he discovered a whole new zoo of knots called rational tangles. Right? Rational tangles are actually very useful in studying DNA topology. And I think I've digressed, but the point I'm trying to get at is better notation allows us to understand things better because it allows us to frame the problem differently. And in Iverson's talk, he actually noted the criteria for what passes as good notation. A good notation, according to Iverson, allows you to express your problems easily. It is suggestive of more things that you can do. It subordinates details. It doesn't take much effort to use, and you can obviously see that it is obviously correct very easily. Now, I can talk at length about each of these properties. In fact, I've talked at length about representing problems. But I want to focus on the next three things: suggestivity, subordination of detail, and economy. As you have seen when I was explaining the inner product, realization of what the dot does suddenly suggests to you that you can put any other binary functions on either side of the dot.
So here the important part is that instead of using a single symbol for a cross vector matrix, whatever product, then we're splitting out the essential operations that are inside it, which are multiplication and addition. So first there's multiplication going on, and then we add up the products, and that is actually what this inner product is. And in APL, we spell it out as plus dot times, but the dot is a dyadic operator, and we can put any two dyadic functions on the sides. In fact, some are relatively common, like or dot end. And you can also do things like and dot equal, where it's an and done on the equality. So here, by splitting it up and showing what the components are, it's suggesting that you could swap out components and achieve new functionality.
Yeah, and then the hard design work is figuring out what those components are. Like what are essential operations for a wide range of domains, for a general purpose language at least.
And there has to be a balance, because obviously you could think that the ultimate suggestivity would be splitting it up all the way down to the NAND gates or the NOR gates, right? Then you could substitute in anything you want. You can make the computer whenever. I think that's why Iverson also has economy, right? It has to be, and subordination of detail, right? Then it would not be subordination of detail. It would not be economy either. It would blow up entirely. And an example of this, I think, is something that came up on the ArrayCast that will either come out before or right after this episode, with the scan. So in APL, scan is a primitive operator, and you give it a dyadic function, for example, plus scan, which is spelled backslash or backslash bar, and that gives us the prefix sums of a list. In J, that has been split up, recognizing that there are actually two parts going on here. There's a summation, which is actually a plus reduction, and there is the formation of prefixes. So it's plus over each prefix of the array.
Well, you can do that with well, in some cases, like summing a list, you can do like a catenate scan.
Yes.
And then plus reduce each.
Yeah, that doesn't work in the general case. It's a bit awkward in APL.
No, but it's quite useful for demonstrating what scan is.
Although then you're actually already using a scan with the concatenation, so it's a bit cheating there. It's maybe better to do the iota length, take each on the enclose of the array. So then you actually get the prefixes taken for each one, and then you apply a summation to each one. In J, I don't know if you know this, a plus scan is spelled plus / backslash. So backslash in itself applies its operand to each prefix, but it doesn't necessarily reduce each prefix. It takes a monadic function, so we do plus / each, but the each is built into that. So instead of being an each, it's an prefixes thing. And then
some prefixes.
If you actually want the prefixes, enclosed or boxed as they are in J, then you can just do enclose scan. It's not a scan then, really, it's a prefixes, right? So they're just enclosed prefixes. That gives it the prefix, and that works without the issues of the concatenation things. But which level is better? Having just prefixes and then summation of each one, or is it the running sum?
I think it's especially hard in that example because in both cases, the work it takes to get to the alternative, to get, in APL, in order to get something resembling just enclosed prefixes or whatever else you might want, is not that much. And in J, to get the plus scan equivalent is not that much. So I feel like that's really straddling the line there between.
Yeah, but that is a balance that the language designer has to deal with. Interestingly, in BQN, it doesn't quite use slash and backslash. It uses like kind of like
grave and an acute little.
Yeah, but they look like superscript
accents.
slash and backslash.
Yes.
And there it even though Marshall Lochbaum, who designed most of BQN, is well familiar with the differences between APL and J and has a lot of J experience, he went back to just having the scan primitive have the built-in reductions, but there's a separate function rather than operator that immediately returns the prefixes, which is monadic up arrow, I believe. And so, but again, that doesn't have the same functionality because it's a function rather than an operator. Then you have to do an each afterwards, and there are certain things that cannot easily be optimized in the interpreter. But then maybe we're going into
interpreter, compiler.
Yeah, should the ease of
implementation,
implementation should that influence how you design the language, or how do you think about it? Do you think about it as applying a function to the prefixes, or do you think about it as getting prefixes and then applying a function to each one?
Yeah.
What if you only want to apply to some of the prefixes? There's another one is inner product. BQN doesn't have inner product as a primitive. J does, but you have to include the reduction. So it's inner product is a kind of a reduction. It's a reduction of the other function. So plus dot times is actually a plus reduction over some of the products. It's actually plus reduction over the diagonal of all the possible products. And in J, you spell that as plus slash dot times. So plus reduction dot times. And then because of J's word formation, you can't have a slash and a dot next to each other, so you have to have a space. So the whole thing becomes plus slash space dot asterisk instead of APL's plus dot times. And at that point, I start going, no, this isn't as nice notation anymore. I understand it's more general, but it's actually quite rare that, for example, I need the prefixes. It's almost always a scan.
So I was kind of thinking, yeah.
But there's a line there. There's a level. You can't just blow everything up, and you can't hide everything either. Then it's too much. And plus slash, time slash, and so on is probably good instead of having sum and product, and running product. But it's interesting. I don't have a final answer to which level it should be at.
And this is what suggestivity is. Your code suggests new code. Your solution suggests new solutions. Think about this. Are there any data engineering products out there that does this? Now, let's talk about subordination of detail, right? I think it's pretty given in modern day programming that abstraction is a good thing, up to a certain point, that is.
Aaron Su begs to differ.
What? Abstraction is a good thing. Well, it's again in these levels, it's necessary at a point, right?
Yeah, but at what point? It's again, there's.
I was actually gonna pause this to come back on the data engineering tools do suggestivity, and it's like, well, it's this Zen of Python thing, right? There should be ideally one normal, good, or whatever adjective way of doing a certain thing. Which is nice because then when you Google how to do X in Y, it comes up with an answer, and you can just plug your bits in, and then you're happy.
Hasn't Python abandoned that idea though?
I don't know, maybe. Yeah,
'Cause
well, I suppose notationally, because they've got all this like mapping Lambda stuff that's becoming more popular.
they've got the list comprehensions.
Yeah, list
And they
comprehensions,
also
which
have normal loops, so you have to choose.
so maybe. And then on top of that, with the ecosystem, yes, you've got packages for everything, but I imagine, I don't use it often enough to know, I imagine for certain things you've got several competing packages.
Must be.
I know that's true in the JavaScript world.
But there it's gone completely out of hand, right? We're drowning in libraries.
Actually, even though I do use some things where I look and it's like several GitHub repos that are all Python packages doing something similar, but they're all a little bit different.
There are these ridiculous, or maybe they're joke libraries for JavaScript, is number, and is even, is odd. And and I think a common example of it, one of your favorites, is the cutting, say, a text into pieces. Yeah, you might think that it's very simple. Just you cut on something. But there's so many, there's so many different ways actually to do the cut. What happens if you have a trailing delimiter? Does that mean that you have
empty partition
at the end or not?
Ignore it?
What happens if you have multiple consecutive delimiters, leading delimiter?
And even just like implementation wise, is it JavaScript? It's got slice and splice or something like that. Like one of them is, I mean, that's actually very different to what you're describing, where one of them gives you a new value that is the text split into substrings, and one of them modifies the string itself.
Oh, I see.
Yeah.
No, but that's not cutting.
It's not the same as behaviors or
trimming it. But the splitting thing, sure, you can make a function in APL utility function for yourself called split, although that's an unfortunate name because it has so many letters in it, split, that it's often more letters than the number of characters in the definition of it. So you might want to use cut instead.
There's also a primitive called split, so that could be confusing.
So you call it cut, and then it's only 3 characters. You're actually saving space by defining cut in 3 characters. Although you might need spaces around that word cut. But then you can't see what exactly does it do. And then later on, you come back to the system, you want to extend it, you need to cut something. Can you just use the name cut and rely on it doing the right type of cutting that you're expecting? Or do you have to go look up its definition? And it's so short. What if you just wrote the APL code inline every time? Yes, you're repeating yourself. Maybe that's not a good principle to adhere to. Don't repeat yourself. Because if it's short what you're repeating, and people can see immediately what it is you're doing, rather than having to go look up what it is you're doing, that might actually be a benefit. Remember, the code is read much more often than it's written. So you have to type the same thing a couple of times, sure, but the reader doesn't have to go and look something up. Even if the IDE provides, you hover over the name with a mouse and it shows you the definition, but it's still more than just being able to directly read something. A fluent APL reader can read one of these idiomatic ways of cutting things.
Small enough,
yeah.
That's the limit, really.
That's a handful of primitives in a train or so.
Yeah.
I've read a bunch of writings from Iverson, and I'm convinced that he's actually one of those few people who knows the difference between abstraction, aggregation, and agglomeration. The differences between these 3 things are very subtle. They all sort of mean taking many things and making one thing out of each other. So let me give you a sort of 1-minute version that won't really do it much justice. Abstraction is basically hiding your things under a name. And if you come from the Lambda calculus school of computer science, your basic form of abstraction is wrapping things in a function. If you come from the Java school of computer science, then you've got more ways of abstracting things. You can use interfaces, you can use subclasses, and so on and so forth, right? Aggregation is basically the same thing, but you get rid of the underlying details. When I talk about the average height of all Australians, I don't actually mean every single human being. I've forgotten about them. I only talk about the average height. And lastly, agglomeration is basically referring to a collection of things, and you always refer to the collection of things. And that is what subordination of detail is. When you write inner products in APL, you always write the same 3 symbols. You don't write np.dot as you would in NumPy. That's abstraction. And subordination of detail is actually a very useful tool. Imagine if you can have the whole function in front of you every time you try to solve a problem. How would that change the way you solve problems, right? Now let's talk about economy. Earlier when I gave the Spark example, there was an example of a lack of economy. To do things with Spark is generally very hard. You've got to do so many other things just to change one small thing. I also mentioned earlier that with the Einstein summation thing, that it works mostly on pen and paper because working with equations on computers is not that great. And when you work with Maple, for example, it doesn't give you that sense of manipulation that you have with pen and paper, right? So when I said writing engages your brain in systems 2 thinking, it comes with caveat. You need to be able to manipulate your thoughts efficiently and quickly enough, right? If you're bogged down trying to get your thoughts into the medium, into the computer, into the paper, by the time you come to manipulate them, your ideas will have already evaporated. So for a lot of things, pen and paper still rule supreme. But having to transfer that writings on pen and paper to a computer would mean that you will need a different set of notation for your computer. And this ties in very neatly to a principled statement I want to make. There is no one notation to rule them all. Like it or not, we use multiple languages and multiple notation all the time.
Prize in Mathematica.
And in more context than you can.
Yeah, okay, I hear.
Isn't that what the Mathematica project is? Some kind of like attempt towards. Maybe that's a too bold a claim from someone like me who doesn't really know anything about it. But
I think it
supposed to be
tries to
just-
be more than just mathematical notation written into a computer.
No,
But I
it's
think
it's trying to be one notation that
one notation to rule them.
to rule them all, right? You put in what you
it's
want,
it's
and
not a
the
notation
engine figures it.
for everything, right? It's a programming language, but it's not a good notation for certain other things that you might want to do.
No, and to be fair, actually, you do notice this at least in Wolfram Alpha is you put in. It's more like a kind of Google for computational things.
Okay, that Wolfram Alpha is a natural language
model thing.
understander, whatever it is.
And then it gives you back stuff that's in the notation of whatever the domain is you asked for, the diagrams that are appropriate, the mathematical formulae, etc.
But it parses things down to, or whatever you call that processes the natural language, builds up a Wolfram language or Mathematica formula and then presents that. It doesn't necessarily it doesn't come back with natural language results either. You can hook up one of these artificial intelligence engines for that. They've already done that. So that they can take those clear and precise results and make them fuzzy and human looking. No, but I think I'd rather go into the comparison here between Iverson notation, that early proto-APL thing that Iverson used handwritten,
right. Yeah.
or in print, but that was a nightmare to print, and then APL, right? Now, when you actually need to make it into a programming language that you could use, it can't just be the same. And I have experienced this as well. I've tried. I mean, occasionally I would use APL in handwritten. I remember when I was in high school, I tried using APL instead of traditional mathematical notation for manipulating things, and I found that it wasn't as pleasant, actually. I kind of missed the regular notation. Had I used Iverson notation, I might have been best of both worlds.
I noticed that when we've been reading these papers recently, and some of the things look just tighter and neater from the perspective of someone handwriting it in order to manipulate expressions to get to a result. Like you were allowed to. So the two ones that come to my mind are not is an overbar like it is in Boolean algebra. Traditional Boolean algebra, it's like a bar over the top, and then you can put bars on your bars, so that makes this nice neat expression for De Morgan's law.
It's like a square root without the rooty thing on the left, right? It's just the overbar. You're allowed to put square roots inside square roots and so on.
That's true. Yeah, you can do it with square roots as well.
Or for example, also division with a long horizontal bar.
Squaring squares, you can exponentiate all the way up if you want. And the other one being the inner product, which in the early examples, which are a lot of descriptions of low-level computer systems, like here's the algorithm for fetching an instruction from a register. There's a lot of inner products there, and the notation for that, which is like the, for us, left operand on top and the right operand on bottom, actually looks really nice compared to spreading it out.
Right. Yes. Inner product does look a bit funny when you're handwritten. You can also see how the outer product notation comes from there. So if you see an inner product as reductions over the diagonal of the other operand applied, then if you don't do that reduction over diagonals, then you just have an outer product. So if you have these two symbols on top of each other, so what we have today, plus dot times, is just plus on top of a times, much like you write like plus minus.
Yes.
Then but just on top of each other. And then if you put in a null symbol, a little empty circle instead, at the top one, then you don't do that post-processing step. And then spreading that out on the line to be three symbols, giving that positional thing a symbol, just like exponentiation got a symbol from previously being positional. Then you have the null symbol on the left, which was the jot. So that's how we got jot dot times, for example. But there are more things, right? There, in those old notations, you had implied sizes. So you could have like a null vector or an all one vector, and they auto size to match the other argument. Or even more than that, you could have a prefix vector, right? So they had these alpha and omega, they would form prefix vectors, suffix vectors, meaning they're all booleans, but they have so all zero, but they have three leading ones or three trailing ones. Like, but you don't have to specify the size because it just has to match the other argument, right? Which is fine in handwritten, hand-reasoned math. Everybody will understand. It gets a bit hairy when you do it with a computer. Although, I mean, I guess you could have, if not for some oddities and how things have been designed.
You could definitely model that as an operator if you so wanted.
Yeah, you could have it so that you have a mask on the left of replicate or compress, and if you don't give it all the elements, it just pads with sufficient zeros for the rest, or ones, or whatever you would decide should be the defaults. It could be done. In fact, we've done that with partition. No, partition enclose.
I'll give it a short left argument.
Yeah, you can give it a short left argument, and then you will just assume the rest of them are zeros, which means continue this partition, and leads us to some things that I didn't even, when designing that, I didn't even think about all the fallouts of that. But something I find really nice is we can now write, so it's left shoe for partition enclose, and you can write 1 partition data, and that gives us head and tail. First element is a separate vector, and then all the rest of them after that. I find that
that's very nice.
And you can take a head of a certain size by having zeros. So if you want to take the first three elements and the rest, you'd write 1001, and that chops it. I think that's pretty cool. Anyway.
Yeah, let's see what other notations we got.
I'm going to quickly enumerate through them, but the easiest example would be specification and implementation languages. In many other words, it's the type language and the term language, right? So in languages like Go, it's not very obvious that you're writing in two different sets of languages, when you're writing things like function signature. But if you use languages like Idris or Haskell, it is very obvious that you're working with types as one language and working on the terms as another language. And sometimes of these specification and implementation language, only one of them actually makes it out into the medium. Take JavaScript, for example. The types are still there. It's just stuck in the head of the programmer, right? You don't write the types, but it's stuck in the head of the programmer. And because every programmer thinks differently about types and thinks differently about the programs, what you have is you have 1,000 different type languages, essentially, for every programmer that touches the same JavaScript program. Another clear example is when we need to work across different computational models, right? We drop down to writing regular expressions all the time, and when we need something databasey, we write SQL. In these two examples, regular expression and SQL, it's very clear that you're writing in a different notation. But equally, what I want to point out is that if you use things like LINQ or SQL Alchemy or Snowpark, you're working with the same language written differently. Think about that. Your df.groupby is exactly the same as SQL, but it's written differently. Okay? And this is something I'll talk about in the next few minutes. The third way that we can use multiple notation is in hierarchical use. Right? So Naughty Dog, a game developer of Last of Us, had developed a new programming language called Go, which is a Lisp, and it works as a scripting language over the core, which was written in C++. And if you're interested in Go, by the way, there's opengo.dev, which tries to reverse engineer Go, and it's pretty cool. There are other ways of using multiple notations and multiple languages. Come find me after the talk if you want to know more. The point I'm trying to make is that we do use multiple languages and multiple notations all the time, at the same time, by the way. And this is useful, right? Who here likes to solve problems on Project Euler or LeetCode, I guess? No? Okay, so one of the funnest things that you can do with Project Euler and LeetCode is that you can solve the same problem multiple times with different languages. And when you do so, more often than not, you end up seeing the problem in a different light. And I like to call this binocular vision. Each of our eyes take the scene in front of us and see a different, slightly offset and different planar projection.
You could also, if it's cheap enough to implement, if it's low enough effort to implement some algorithm or algorithms in general, then you could also stay with the same language and solve the problem in various different ways. It doesn't have to be different languages.
Well, that's very fun for the... Well, it's something that you practice with those types of Euler and LeetCode problems, but then actually when you're writing real applications, ends up being a bit of a benefit that you have those different perspectives ready to go.
I think it becomes even... I haven't participated in LeetCode and Project Euler, so I can't really speak, but I would assume that when you solve the problem, you solve the problem. Whereas specifically for code golf, where you're looking for the shortest solution in characters, there's very much an incentive to scrap everything and start from scratch with a different approach. Because maybe, even though the final result will be the same, but maybe it will be shorter to write it this way. Not because code in itself should be as short as possible, although brevity is in general good, economy. But here, this pushes you to try things out from different angles. And he has the video here has a quote by Alan Key. How do you say that? Alan Key. A change in perspective is worth 80 IQ points. Hey, a change in approach is worth 80 bytes in code golf too. So.
Of the scene in front of us. And when you put them together, you actually see the scene in front of you with greater fidelity. So now we can ask, what are the properties of good notation, right? When you want to talk about good notation. Here are listed 3: interrupt, fit for purpose, and that they're distinctive. Data engineering products, by and large, fail all 3. This is because, as a community, we're somehow stuck with the mindset that there should be one notation to rule them all. And this is rather backwards. We want one environment, multiple languages. What ends up happening is one language, multiple environments, right? We don't want that. And the cynical version of me would say, we end up with that because, environment capture is richly rewarded by investors. I'm just being cynical, right? But let's talk about an interrupt. When I say interrupt, I don't mean, let's just all use gRPC. And that's one form of interrupt.
I think actually...
What I talk about is interrupt.
Yeah, how do I get this? Thanks. I think actually it might speak more to the difficulty of defining good standards for interop. Like if the goal is to have one environment where everyone writes a tool, a notation or whatever that works in that environment, then ahead of time you have to kind of agree or hope that over time, a little bit like HTTP, I guess, because
Yeah,
that's
I was
such a
about to bring that example
because
up.
that's
Yeah.
like one where like every tool's talking to each other over HTTP. So maybe it's not a disaster, right? Yeah.
Oh no, but the problem is you might not imagine the needs in the interrupt from the
Of that
outset.
other.
So you make a standard like HTTP, which is all great, and then you find out that you want to use this in a more interactive, immediate fashion. You need WebSockets,
Yes, right.
and then you could uh, come up with something ad hoc for that, where the server and client agree on how to communicate, but it's not in the standard from the beginning.
It's also not really an answer to the question I've just thought as well, because when when you think of one environment, you can also imagine like literally, I've got like a VS Code up, and in one tab, I've got some like APL that I'm iterating on, and in another tab, I've got some like JavaScript that's doing something, and in another tab, I've got some like Python thing that's doing something, or whatever it could be. But then what you really want is to iterate on all of those simultaneously. Like when you drop down into like you don't well yeah, you sort of do your regular expression, then you move on, but it's there in the same environment as the rest of the code, in whatever language.
But why do they need to interoperate if you're saying they're part of one system?
Potentially, yeah. If the
Yeah.
idea is that different notations could be good for different. I mean, this is what someone said in a Arraycast letter. Um, about like should try the Raku language, which was Perl 6, and apparently like that's a very pleasant experience in terms of uh, it supports lots of paradigms fairly richly, and so you can. I mean, at first you'd learn it, you won't know them, so you'll sort of be clambering around different problems doing it the way that you've sort of learnt so far, but maybe you'll pick up a new technique or a new style of coding something, and then turns out that like, oh, for this problem, do it this way, and then for this other problem or part of the problem, actually you want to do some other mode of working. Um,
But
but that's
I can see issues here with we mentioned before also types. Uh,
mm,
interrupt between things is very hard if they don't have types that map to each other.
yep.
So and we see it very much with APL, and we have this quad JSON, for example. So we convert an APL array to JSON, and there are things that you cannot represent properly in JSON.
Mm, like they're
There's
null.
not just well, null is not really the problem, but um, but an enclosed array, a scalar that contains stuff. Just enclose one, two,
Mm.
three. It doesn't exist on the JavaScript side.
Oh yeah,
That's just the one. And multidimensional arrays is maybe the biggest thing.
yeah.
Yeah, you can do list of lists, but they or arrays of arrays in JavaScript, but they would more correspond to APL's vectors of vectors.
So then you've
How do you
yeah,
distinguish between
exactly.
a vector of three vectors and a matrix with three rows?
So again, that's something I think has evolved over time. Of like most languages use list of lists,
Oh, but
and they
it's
don't really
not the
think.
same thing when you have
No, no, but I
both,
mean,
right?
for they can all interop in that way.
Sure, and we can interrupt with that to APL too, but we can't, but the other way doesn't work. And then
Yeah,
there are
but
some
it's
things
not
in
smooth.
JSON that we cannot easily get into APL either, or it's not clear how you should. When you have Booleans, true, false in JSON,
Mm,
but in APL we don't distinguish between 1, 0 and other numbers.
yep.
And how should you import it? It's not so obvious. Um, and
Is that a setting? Can you choose
can you
one?
choose to have them 1 and 0?
I know that
I
you
don't
get
remember.
yeah, by default it'd be like enclose quote true quote.
Yeah. I don't remember if that's a setting. We might.
It's
Problem is that
it's almost
doesn't
definitely been
round trip.
discussed, but I don't know.
Yeah, it
Well,
doesn't round trip. Whereas nulls, you can import them either as, again, an enclosed character vector null or our special quad null value thing. But at least that round trips.
right.
Another thing is dialog APL doesn't have infinities, so for our JSON 5 import, we have to deal with positive, negative, infinity, and then as well. But we just do enclosed character vectors because they are not ambiguous, because you can't have enclosed
What's
character
that for?
vectors.
Is that specifying an upper limit, but you don't want one? But
What,
you must have that.
infinities?
You must have that field filled. Yeah. In JSON 5. Oh, I guess because it's
JSON
data.
5 is just just
Yeah,
ECMAScript
yeah, you're right.
5,
We're
right?
we're using it for config mainly, but it is a general data
Yeah, it is. And JavaScript has
format.
infinities because IEEE floats have infinities and done, right? Do you actually need infinities in JavaScript? Probably not.
Yeah.
I don't know, that's interesting. Other than directly mathematical things where they're using JavaScript as a calculator, I don't think I've ever seen anybody use
No.
use infinities for any useful purpose. Same thing for nans, really.
Mm.
You don't use them, you just use them to detect
Yeah.
that something went wrong.
Yep.
And then occasionally you get the form that says, this thing costs nan dollars per pound or something, right? Something good.
Does that
Somebody
mean it's
good.
free or very expensive? I don't know.
Oh, that's not a number.
Damn, we both clicked.
Form
You
of
click. You click.
The gold standard for interop is when you write arithmetic.
That's APL. Though.
Yeah.
Sorry.
You don't realize that you're dealing with a completely different language, right? So this is a very well integrated example. But there's another language that does not have numbers or plus or minus built.
That's right. He means that this works in all of them, I guess.
Except Lisp.
Like notation that interrupts in all the environments.
That's different, no? Interrupt and there's portability.
Well, okay, this is portable. This is
So 1 plus 1 is
to all
portable
languages.
except Lisps.
Except Lisps.
And
yeah.
And other such Polish and reverse Polish notation.
Yeah.
Things.
That's pretty good.
I was just teaching somebody.
Sorry.
Oh, I was teaching somebody some APL this morning, and showing how dialog APL integrates with .NET, and that has a really, really good interop. Where even though the array model differences and type system, that's not really there in the APL, but automatic casting and so on is going on, and overloads of APL primitives. So something we were looking at is we're using .NET to create a datetime objects. So some datetimes, and then we can use the APL primitives greater than, less than, so on, to compare them, and that just works. That's, I think, is very nice interop.
Yeah, that's really nice.
Lambda calculus, for example. All right, this is how you would write 1 plus 1 in the pure lambda calculus with church encoded numbers. Right?
What?
Let me ask you this: would you want to write this on a day-to-day basis? No, you would prefer to write the first one, right? So with this that has a high bar and a low bar, I want you to consider the tools and languages that you use for your everyday work.
Shouldn't we read what it says for the listener?
Sorry, yeah, great point.
So the gold standard is 1 plus 1. Now you can do the lambda calculus standard if you want.
It's poop emoji standard according to this slide.
As opposed to gold standard, yeah.
Yeah. And it's lambda m dot lambda n dot, hope that comes across, dot lambda f dot lambda x dot lambda, dot mf.
Oh, come on, you gotta start over now.
Yeah, right.
You made a mistake. Lambda m dot lambda
n dot lambda f dot lambda x dot mf open paren nfx close paren lambda f dot lambda x dot fx lambda f dot lambda x dot fx.
Yeah.
Do you know lambda calculus?
Not enough to understand what in the world's going on here. I learned a little bit from you looking at these things about combinators and dyadic operators in APL versus combinators. And
Maybe we should do that as like a homework, is choose a notation and look into it for comparison and contrast. Because I feel like I don't know that much about I'm like aware of all kinds of different notations for things, but I haven't never tried to use most of them in any capacity. So I think that'd be interesting. Anyway, the point being, lambda calculus 1+1, very verbose. Traditional mathematics.
It's not good for adding numbers, let's say like that.
Yeah. 1+1, very concise, very good.
Yeah.
Where on the scale does it fit? It most likely fits somewhere in the middle. And we often have to import libraries to use.
This is the whelmed standard, so neither over nor underwhelmed, simply.
Oh, I see. It's just
whelmed. Yes.
The Whelmed standard says it's. I don't know if this is a particular language or it's just a pseudo code. It says 2 code lines. Clearly, they're code lines. It says import arith, and then the next line says arith.add, and then it has a parenthesized list of arguments, which is arith.1, arith.1.
Very strong type. Well, no, everything's an object. Anyway, it doesn't matter.
Everything is an object. Well, I don't know if
one is an object.
Yeah, well, one is something
one
that
is a member of an object
inside arithmetic, right?
Yeah. Anyway, so yeah, somewhere between 1+1 and lambda calculus hell is this whelmed standard.
Lambda calculus is probably not intended to do the basic.
No, of course not. No, it's further.
Yeah.
Use another language, basically. And that's okay. But if that's the pinnacle of human design programming languages, I would be very, very sad. And yes, to the lone lisper at the back of the room, I hear you, mate. But I think there are better things like tree calculus in the future. So let's go back to properties of good notation, shall we? Here are the reminders. We've talked about interrupt. Now let's talk about fit for purpose, right? How do you know that your notation is fit for purpose? Well, to misquote Einstein, it should be as simple as possible and no simpler. So contra program, we should not be using the most powerful language. We should be using the least powerful language. You should not be using a Turing-complete language, right, to match a string that's written in a regular language.
He says he misquotes Einstein. The actual quote that he's showing is, "It can scarcely be denied that the supreme goal of all theory is to make the irreducible basic elements as simple and as few as possible without having to surrender the adequate representation of a single datum of experience."
Use a regular expressions engine, and fortunately, most programming languages nowadays do actually have a regular expressions engine built in, so the process is quite smooth. Oops, sorry. So let me ask you this, right? What about ETL and the other things that data engineers do, right? A very common thing that we do nowadays is to have microservices, and we would.
No, I think I looked up what ETL stood for recently. What was that? But I think it's to do with getting data in and out of systems and between them. I can't remember what it stands for now. I'm sure I looked this up recently because I was reading something. Anyway.
Probably
describe our operations written in YAML.
Yeah, if you look it up quick, you can let us know.
Extract, transform, load?
Yeah, that's right. So yeah, like I say, you're getting data between systems, so you might have to transform, the format of them in order to get it into one place or make it usable in one place or another or whatever.
I see.
It's kind of the stuff at your interface level. Right.
Yeah.
And we submit them to the microservice or product, and they will pass the YAML and do the thing and then pass it on down the pipeline, right? The notation used is universal, it's YAML. But more often than not, it's not fit for purpose. And that's why we have to come up with hacks like templates and YAML. You guys know what I'm talking about, right? Cool. So the last property of good notations is that the notations are distinctive.
What's the problem with YAML that he hasn't in mind? YAML is very complex, right? There's a lot of stuff you can do.
I hear people rag on YAML a lot, but I don't use it enough in any complex fashion to really know. The only thing that's a bugbear of mine is, what do I use it for? Some So I think muckdocs uses it for the config and some other GitHubby Jenkinsy. No, because that's using Groovy, isn't it? Anyway, see, yeah, I use it for some things, and in lists or when you have members of an object, then if I've got the white space wrong, then it complains. And
So does Python. Or maybe
yeah,
that
well, I
gives the
don't do
wrong
enough
result.
Python to really get annoyed by that. But the other thing is I've got like tabs as default in my Notepad++, but then sometimes I'll get something and it's got like spaces, and then I'll have to like decide to like change my whole mode just to accommodate that or whatever. That's a different debate, but I know that, yeah, that's the only thing I imagine. Well, yeah, I think it
I
came
know
up.
it's complex, but there
Came
are
up
lots and lots of rules.
yeah.
Yeah, I mentioned something about, I think it's a famous thing that they don't like, or infamous thing. They don't like YAML in Norway because of
Oh,
different
that's
ways
right.
to denote booleans, including yes and no. And then when you have country codes, and they have the country code for Norway, it's NO, and you get false instead.
Yeah.
Because they try, I mean, it's intended to be nice for people to use, so you can omit quotes in strings, except if it's reserved words and characters. But it's
You
maybe
end
they
up
made it
having to
too
learn a
nice.
bunch of exceptions, basically,
Yeah, and I, as
instead
soon
of
as you
having
have
rules.
something smooth like that, then there will be all the exceptions to when things aren't as obvious. Markdown also has these kind of issues. Right? There are things that when you want to write them in Markdown, it gets really awkward.
Yeah.
For example, people write this. It's called an emoticon,
Mm.
shrug emoticon, which is easy to type in, or mostly type in APL. I type it as the negative symbol,
That's
backslash
the high minus.
underscore. Yeah, right. The high minus backslash underscore open paren, and then I use the commuter tilde the arrows symbol because that's like the face thing. Close paren underscore forward slash and high minus.
Yeah.
Um,
So it looks
and
very like this.
but then a markdown processor might think that the underscore something underscore should be in italics, or maybe that backslash that's there after the
So
initial
then
high
what do you do?
minus.
You surround it in back quotes, so it's a code, so it's
So it's code.
code
No,
block.
but because then you have the backslash,
Oh, so you just escape
escapes
them.
the underscore. So even if you wrap it in backslash in backticks to be code, it might think that you're escaping the underscore, and so it just renders that a single underscore, meaning that the emoticon dropped an arm. Uh, so something that can be very nice in some contexts, it might just muddle things in other contexts.
Mm.
What I mean by that is when you're working in one language and then you move to a different language, you will know that you're working in a different language. I know I cannot be the only one who gets stuck in piles of CloudFormation with YAML just to get that bloody SageMaker to do the thing I want to do, right? So when you have layers and layers of non-distinctive language, you're going to have A, be in trouble, or B, you're just creating another reason for that a new startup to exist in that ecosystem picture I showed earlier. Now, so far, the things I've been saying have been very abstract and pretty far from what data engineers do. So let's bring this back a bit. What exactly are my recommendations, right? The tools exist in the market, but they're not the things I prefer to use, but I accept that they exist, and I would use them. Instead, we can focus on the process of solving problems. I want you to take away from this talk the way I framed problem solving. I want you to think about how language is used to constrain a problem space. Now, think about how you can enable your team to work with individual flair and yet cohesively as a whole organism. Now, I want to impress upon you that the solutions that we have today are pretty damn terrible, right? So I want you to go and invent specific languages for your specific problems. I want you to solve your problem multiple times with multiple languages, and then take a step back, right? I want you to then look at it. How are they different from one another? How are your solutions similar to one another, right? Study what unifies the difference, because that's the core of your problem. Solve that, okay? And if you do that, you also reduce the cognitive load that may exist when you have 1,000 languages blooming. Now, and while I won't give you specific recommendations like use Lisp, use Go, rewrite in Rust, I will give you some alternatives that you can take right now. because there are simply other options that are far superior to what we have in industry. Instead of using YAML for all the things, death to YAML, we should split up our notation. For configuration stuff, use Q, use DAO, right? These languages have an excellent verification mechanisms for their grammar. And for your data language, instead of using JSON and having to validate with the JSON types, whatever, use protobuf, right? If you have a process that ingests raw data and put them in some sort of structured SQL-like thing, use DBT so that you can verify that the data fits into a particular schema, right? Use Malloy to break things down into smaller parts that you can look at it and say, okay, this is obviously correct. That way you can manually verify your modules. And all these things, by the way, fall into a class of what Gary Miller calls deterministic name algebra. And if you're a language nerd like me, this is actually a pretty exciting space to be. So now we've come to the end of the talk.
Come back.
What I want to impress deterministic name.
Do I have anything to say? I did try to start looking at these. And then I think the conclusions were like some combination of I'm not doing enough in these spaces to warrant like learning a whole new thing versus like sufficiently getting by with whatever I'm using already.
You often don't have a choice, right? The choice has been made for you, and you need to use some kind of tool, and it's already using JSON, so.
So all I'd have to do is convert my stuff from JSON to protobuf, and then find a protobuf translator importer or write one. I guess that's the issue, isn't it?
It's if you're making a whole system, right? The full stack thing. You need to decide, well, what kind of language am I going to use to communicate between these parts or store this kind of thing? And then you choose these, I think.
I see.
Or not.
Also seems more abstract than thinking about specific problems you're trying to solve. This is more about, well, he's talking about data engineering. This is a data engineering conference, so I guess that's fair enough. Anyway.
In algebra. And if you're a language nerd like me, this is actually a pretty exciting space to be. So now we've come to the end of the talk. And what I want to impress upon you is this, right? Language is the structure of rules and elements of a system. We solve problems by establishing the rules and finding out what exactly are the elements of the problem. In short, we use language to solve problems. When we write language down, we call that notation, and it's used to manipulate terms of language. And I've given you 3 examples of how changing the notation changes the way we look at a problem. You've got Einstein's notation, making neural networks faster. You've got Conway's notation, discovering a whole new zoo of things. And APL, changing the way you think about programming. What I'm trying to say is that we should use more diverse forms of notation to solve our problems. But in modern day data engineering tasks, we're sort of stuck on one universal notation. And this is making a lot of our problems harder to solve because it makes it more difficult for us to think through our problems, right? And we are also creating accidental complexity. So ironically, to make things simpler, we shall endeavor to use specific languages for specific problems. And it may seem a lot, but it makes the overall system a lot easier to understand. With that, thank you for listening to this weird guy giving a rant. Thank you.
It's giving me real how to draw an owl, draw some circles, draw the rest of the owl kind of vibes of like, how are we going to... I've just explained to you how these are really difficult problems that no one's really got a good answer to. How are we going to solve them? And the answer is, go solve them, and we'll see you later. See how it turns out in another 5-10 years.
Maybe it's supposed to encourage people to go and experiment, and
I think so. Yeah. In reality, it's not, I'm not really ragging on it. And also, what can you do? Right. This is how you start doing this, or continue to do this type of thing. Experiment with different languages and tools, and see what really works for your use case.
It's interesting. There are notations, I think, fields where they need to represent concisely, communicate concisely, and something about their field, they will come up with notations for it. And there might be multiple notations for it. Things that we don't, they're not just computer related things. You could call them technology things, but even that is questionable. I was just thinking a couple of examples of notations that are not computer things are dentists have notations for this teeth and what's wrong with them.
Oh, and they read that out.
Yeah,
You,
they
you
have
can hear them saying it when they're poking your mouth, and
exactly. So they need to communicate verbally, and then they write something down that doesn't correspond to what they said, and it's gobbledygook to the patient, but they
yeah.
understand each other. Another one that I don't know if people use this in speaking, but certainly in writing, now is maybe a little bit less used than it used to be. But engines on trains, locomotives, it used to be much more important than today exactly what wheel set they had. So you could have like a steam engine, and it would the front of it could have a couple of axles of just running wheels that help guide the locomotive the right way into a curve, and then you could have say 3 axles of actually
powered wheels.
pulling wheels that tend to be bigger, and then maybe you have a trailing single lead or the trail, whatever, because if you run backwards just lead wheels that I'm not sure why they're actually there. I'm sure there are good reasons for that. But then, and that's important,
Maybe
I
it's doing the
guess.
same thing if it's reversing. Trains can
Yeah,
reverse.
maybe, but
I don't know.
or maybe
I
for
guess they
carrying
do.
some auxiliary weight when there's extra.
But there's some notation for describing
There's
the
a notation for this,
configuration
yeah.
of wheels on a train.
Yeah, and there are a couple of different systems for this notation.
Damn, we should get these. That sounds like a good contest problem that we can devise from passing wheel
It's
describing
one to the other one.
trains.
It's still used occasionally for modern day locomotives tend to be more boring in that they'll just have like 2 bogies that have 2 or 3 axles of wheels. But occasionally you see something like one of the notation is BOBO. So B stands for 2. So that means 2 bogies of 2 axles that are pulling, or Coco 2 bogies that have each 3 wheels that are pulling. And I'm sure that in the workshop or in the planning meetings when they would send out they have this set of locomotives that need to go out and pull these loads from here to there, and I'm sure it's been very important exactly which locomotive goes where and what types they are, and so they developed this kind of notation for it. And sure, you could write out in English or in JSON or whatever what the wheel setup looks like, but it's not concise and it's not so it's there. It's not fit for purpose. Right?
Yeah.
For whatever it is that they were doing. There are also I think even notations for like plugs, electrical connectors, and what the various pins are doing. Those kind of things. So engineering things more than just programming things.
Yes. Makes sense. I think this was a really great talk for getting to step back and like think about, oh, okay, what is it we're actually doing? What is it we're actually using? Whereas a lot of time doing stuff day to day, you can be like we said, you don't really get to choose. You don't always get to choose the tools. You're sort of in a system already, and you're sort of just plugging away at it.
Or even if you do get to choose, but you're so used to doing it this one way, you just keep doing it that one way. Though another way might be better.
Yeah.
Okay, I guess we'll finish up with this. You can check out our little website, apl.show, and it will have some notes, or if you're watching this as a video, then the description of the video will have links, notes to the things that we've mentioned here. And then we'll see or hear you next, well, not hearing you, but whatever. Next time. Until next time.